Hello, in this screencast we're going to take a very quick overview of looking at high frequency in persist. We're going to use a intracranial recording for this. These tools are not restricted to intracranial, obviously. We're looking at waveforms and applying filters. So it works with any EEG. The question is of course, what you interpret from that. Now, this is not intended to replace the user's guide. The indications for use are the warnings in the manual, which is underneath the question mark bar here in the help system. This is just going to go through some of these tools to give you a quick overview of them. With that, let's go ahead and get started. Now, these intracranial recordings, of course, have a lot of inputs or a lot of channels, and let's get a closer look at this by selecting the All button, and that'll be a little off screen, but I'm going to be switching to a different screen in a moment to show you how we get to this. And I'll just reduce the number of channels here, and we can page up and down and look at these inputs. Now, some of these are unused. We've got C labels here. And so if we create a montage for this, one of the steps that we would take is to get rid of the unused channels. And to do that, we'd select it, left mouse button, page down, hold down the shift key, and we can get rid of unused inputs by using the shift key to multiple select and then delete selected. Now the screen goes blank because I've reduced that number of channels. So I just go back to that channels per vertical page, and now I can page up and down. So started with the recorded montage, which is all the inputs to the amp reference. And of course I can save this. I've already saved this as a montage. I called it H2. Because this recording I've named H2, and here we see those labels. So let's go ahead and page forward in the recording to find a place of interest to look at high frequency. So right now we've set the filters here. I'll go ahead and set the low frequency filter to 1 second and the high frequency filter to 70, and we'll page forward in the EEG till we get to a point of interest. Now, one way to look at high frequency, let me go ahead and change the gain here, is to turn off the high frequency filter. That's a little bit unsatisfying for a couple of reasons. One is you can see a little bit of high frequency riding on these waveforms, but as we know, lower frequencies tend to be higher in amplitude and higher frequencies tend to be lower in amplitude. And so going by these little bits of fuzz on top of the waveforms is a little difficult to see precisely what's going on. Wouldn't it be great if we could look at the Burger band EEG, which gives us context? We can see that at the onset of the seizure, these are the spike discharges there, and be able to simultaneously look at an enlarged view of the high frequency. Well, that's what the high frequency display does. I'm going to reduce the number of channels per vertical page even more. And I'm going to go ahead and I'll just leave the high filter where it is. That's okay for what we're about to do. So how do we look at high frequency? I'm going to select the Tools button, and I'm going to go Create High Frequency Display, and I'm going to set the initial parameters for this. Now that high frequency that we saw is showing up is very little bit of fuzz at the top of these waveforms. At 100 microvolts, well, let's increase that gain to 7 microvolts for, let's say, 50 to 150 hertz. I can pick any range of filters I want, but we'll go ahead and pick that to get started with. And when I select OK, it's going to create a montage that superimposes. Ask me if I want to overwrite a montage. I already have the name. It's fine. It'll update that. And now I get this floating display window where I can move the slider, and you can see the high frequency display at 7 microvolts. Let's go ahead and turn that up to 10. There's that high frequency superimposed. I can interleave them by removing this overlap, but I like to superimpose it. So let's do that. The other thing is we've got 10 seconds of waveform on the screen. Let's change that. Let's take that down to 5 so we can get a closer look. So what we're showing up is these little ripples at the top of these discharges. We've now enlarged. We've removed that low frequency component by selecting a low cut of 50 hertz. And we preserve the high frequency here. Again, we could change this if we wanted to go higher, that's fine. Sometimes you'll have bands of noise in a recording environment that may be at some higher frequency. You might have 300 or 400 hertz noise. And so picking a range sometimes can be helpful, where you might select a set of high frequency filters and the whole thing is just high frequency noise. So we use high frequency filters for the same reason that we use the Burger Band EEG filters. That's to reduce the contribution of artifact in this particular case. Now with scalp EEG, we have artifact reduction that we can spatially separate, but in intracranial recording, different environment, of course. So we use filters to help us with that. All that being said, now we're showing 50 to 150 hertz at 10 microvolts. We're looking at the Burger Band EEG at 100 microvolts with the low frequency filter, 1 second. The high frequency filter is off. We can page up and down and see that, well, we can see it right from this very first page. Not all the channels have phase-locked high gamma along with the spike discharges. For instance, this ITG11 doesn't, but this ITG9 does. We can measure it. How fast is that? We can go to Tools, we can go to Quick Stats, drag a box around this, and 81 hertz. So now what other channels do these show up in? If I page down through this, I can see that some channels have this phase-locked high gamma and some do not. Now you can use this on any particular recording, and you can use any particular range of frequencies. In fact, you probably notice here that I had some infra slow set up here, 0.05 to 0.5 hertz. Of course, I'd use much longer page durations, but in this case, I'm looking at high frequency and superimposing it. That's that. If you're using scalp EEG, standard 1020 probably doesn't have enough density of electrodes to be able to resolve that. That's where you start looking to the realm of high density EEG recordings. And there's some interesting papers on how to do that and how to, and you know, what activity of interest you may be able to find. Again, this is just a tool that helps you see those high frequency activity in context of the Burger Band EEG. Enough of that. Now the other way of looking for areas of interest to hunt for this sort of stuff is to look at trends. So I've selected the split screen button, and over on the right I'm showing spectrograms for anatomically grouped sets of channels, and I'm looking at 50 to 200 hertz, and as we might expect with the presence of this high frequency activity, we've got this bursts of it during these seizures. And of course we can look at other trends where here we're looking at 0 to 20 hertz. These seizures all stand up pretty well, as you would expect, since they stand out well in the waveforms. So how do we get here? These are anatomically grouped sets of channels. So we're not doing one trend per channel, we're doing groups of channels. So here's ITG 1 through 8, for instance, ITG 9 through 16, and so forth. Well, let's have a look at that. If we go to Preferences and Trend Preferences, on the Channels tab, this is the montage that's been used for trending, with all those channels available, and these are the channel lists. So channel lists are channels that are grouped that we want to average together, or at least the outputs of those, and trend them as one. So for this AST 1 through 6, you can see I've selected AST 1 through 6. Pretty easy to build, but you can imagine it's a fair amount of clicking to do this. Not terribly complicated though. So if I want to create a new channel list, I select New, give it a name, and begin selecting channels. Now in P14B, that's the way you did it. Now in P14C, which will be out soon, there's a way to do that automatically, and it saves quite a bit of clicking. The other thing I'll show, by the way, this is running in research mode, so I have access to the calculation engines. I've added a couple of engines here for the FFT, and you can see that I've got a sampling rate of 512 hertz set up for this. It's grayed out because I've already processed this. We're going to go ahead and take a fresh look at this recording and process it with a modified FFT calculation engine so we can trend those higher frequencies. Let's do that. I'm going to cancel out of all of this. I'm going to clear the trend results. We're going to erase them. That's okay, because we're going to start from scratch. And to do that, I've got a clean persist 14C window setting up here. I'm going to open up a recording of interest, and using the database, you can point this at a file store and it'll index those and makes searching for things of interest much easier. I'm just going to select HF here, and I'm going to pick the recording we were just looking at. Now what we've got here are a set of scalp trends. We're not going to use that for processing this. Well, how do we get to a set of intracranial trends? So let's go ahead and just show the EEG for now. Again, it all starts with a montage. Now, if you're using a recording that is in the original system or original equipment manufacturer's format, then in most cases, or in many cases, you'll have an option to read the acquisition system montage. There'll be a menu that appears here automatically if it can read that. And if there's referential and bipolar montages available, you can read those from the recording, and then, importantly, you'd save them to persist. But in this case, this has been stripped of all that. It's in persist format, so we're going to start from scratch using the automatic montage creator. Now, if I didn't have that automatic montage creator, what would I do? Well, let's select all button, I should say. I'm going to reduce the number of channels. And the first thing I would do, if I didn't have that build, is I'm going to pick the channels that I want to remove from this montage by holding down the Shift key and then selecting the last one. They're all highlighted, and then delete selected. Of course, I'm showing a subset of which I've just removed a bunch, so I just refresh this. I can go to all, zoom in and out, and these are the ones that I want to keep. So in this case, I'd right-click and save the montage, and we'll call this, just name it after my recording, and call this reference. Now, if I wanted to create a bipolar montage, well, right-click, create montage. It's not a scalp, so I don't need this head stamp. I can go to all, and let's say I want to create bipolar. Select bipolar and begin clicking electrodes. Imagine this could take a while for an extensive set of intracranial electrodes. In P14C, you'll have a way to avoid having to do any of that in this case. So let's click cancel. I'm going to discard those changes, and I go ahead and delete this montage. I'm not going to need it. We're going to go back to the recorded montage, and we're going to show all the channels just to show where we're starting from. And in 14C and later, I have an option to create intracranial montage. So under the montage dropdown, create intracranial montage, and it reads the prefixes of all the channels. And I can decide, well, where before I had to shift select to remove the C label channel, so I can just click over here, remove those C label channels from the montage. Now for those sets of electrodes where I was creating anatomically related groups, well, this is where I can do that automatically. So this is not a 1/48. I can actually increase this and change the number of rows and columns. So you can also decide how many channels per trend. You can say whether it's lateralized or not. Anyway, with this, once I've created the montages, I can just call these all HF, or I could leave this patient name, which isn't a real name, obviously, and the date on there. Select OK, and I'm going to do across rows and columns for the grids, and now it's created the montages, and there they are. So when I select this, I've got bipolar montages. Those overlaps are taking anatomically adjacent channels and overlapping them so that when you're paging through the recording and we get to something like a seizure, you're still looking at all the channels, but it's overlapping them to give you a little bit more vertical eye relief there. But let's go back to what we were doing. This is the bipolar montage for this. Now to create trends, if we go to preferences and trend preferences, this was that first stop along the way for creating channel lists. These are the scalp ones. Let's go ahead and switch over to that new bipolar montage. And there it is. It's already created our channel list for us. So that saves quite a bit of clicking. Now let's go ahead and Go into modify template mode. So we'll create trends for this. Modify template mode opens up this dialog. I'm going to pick this IC blank one, which is a trend settings file that just has my FFT engines set up so that, and some initial trends set up so that I don't have to create these things from scratch. I can replicate them. Well, how does that work? So I'm going to go ahead and go to Preferences, Trend Preferences, and we're going to do Save As. And we're going to give this a name, so I'm not overwriting my template file. I'm going to call this HF2. And it's changed that in this title bar. It's showing me the MMX file. If it still had the previous name in there, then you'd want to select Open and select that one that you've created. So I'm not modifying my template. I'm saving it as, giving it a name, and I'll build stuff from there. All right. Now, one of the other things we're going to look at is the FFT engine parameters. Now, in 14B and earlier, you had to hold down the Control key and then select Preferences and Trend Preferences to show the calculation engines. In 14C, you won't have to do that additional step. So here's the FFT engine, and when I select Edit, I can look at its parameters. Now for scalp EEG, since the FFTs are showing 0 to 20 hertz, we don't need to calculate up to half the sampling rate because it's not being looked at. And so what Persist does to help keep the results files from being unnecessarily large is you can set a subsampling rate for those. By default, in scalp recording, it's 64 hertz, which allows you to calculate FFTs up to 32 hertz, Nyquist. And so in this case, let's say I wanted to do up to 128 hertz, then I would set this to 256. Now as I'm changing this, I'll just go ahead and double this. As I increase the sampling rate, if my points per window, windows per epoch remain the same, when I increase the sampling rate, as you'd expect, the epoch duration is half of what it was. Frequency resolution goes there. So what we want to do is keep in mind that we want to be mindful of not calculating a lot of FFT bins that aren't going to be shown or aren't going to be used, because it can bloat the results file size. And so if 64 hertz is enough, you can do that. If you wanted to go up to 128 hertz, then we would do 256, and that lets me go up to 128. And I can look at my epoch duration of 8 seconds. If I'm happy with that, I'll leave it there. And my frequency resolution of 1 hertz. Again, these are inversely proportional. So as I change the points per window, you can see that the epoch duration and the frequency resolution change as well. So there's an inverse relationship there. All that being said, the important thing to keep in mind is, in this case, if I want to go to 128, I have to set this to 256. Now, why don't we set everything to 256? Again, if you're not going to be looking at those high frequencies, why calculate and store that data? All right, so that's what that's set to. And I'm just going to select OK to close that dialog. So we've got these trends here that don't have any channels with them. So let's go ahead and configure this, because I'm going to replicate this. And rather than having to click on each one and changing, I'm going to set this up and then replicate it. It saves me from having to go into each one and change it. So right now the spectrum is going 1 to 32. Let's say I want this to be 128 hertz. Click OK. There we go. Now this symbol here, earlier version should have a question mark. There is no P1 to ref in this recording. And so what I can do is I could select something from here. Let's make sure we have the montage set. Go to Trend Preferences, Channels. Aha, I don't. I want to make sure I set that montage appropriately. To have my channel labels, save that. So now when I click the drop down here, okay, I see the channels that are in this recording. Fine. Now you can hunt around in this, or you can just right click, go to Trend Properties, oops, right click, go to Replicate Trend, I clicked a little higher there, all lists, it automatically picks the lists. Okay, now I've got my spectrograms. And I'm going to delete this, because that was my first one. That didn't have a channel to go with it. So this still says 0 to 20 hertz, but once you begin processing, it'll update that labels just to check, go to spectrum. Yep, 1 to 128 hertz. Great. So that said, now we're going to look at versus baseline FFT. Those, well, we'll see the reason in a minute. This calculates normalized z-scores from a range that you use to mark an empirical low. What's nice about that is FFT spectrograms, because as we saw in the high frequency display, high frequencies are bigger, lower frequency or faster frequencies tend to be smaller. Using z-scores, it corrects for that. You don't have to worry about getting that gain just right to that extent. So let's go ahead and replicate this. Right click, replicate trend, and I'm going to replicate it across these. Done. And I'm going to delete this. So I've got my versus baseline trends, and let's go to rhythmicity. Same thing, right click, replicate trend, all lists, done. And this first one that doesn't have a label, I can delete that. So once I'm done with this, everything is the way I want it, I'm going to go here, I'm going to save this so I don't lose what I've done, and I'm going to click process and see what we get. And as predicted, it's brighter at the bottom and darker at the top. And we'll go ahead and scale that. Now here I've got this set to show values. I'll go ahead and turn that off. We can see the range, 1 to 120 hertz. And this is the gain, 0 to 10 microvolts. Square root values of that. It helps flatten the values a bit so you don't have quite this disparity between lower and higher frequency painting, as it were. It takes the square root values of each one and then renders it. By default, you can select other ways. So brighten it up a little bit till it looks properly done. And we can set a baseline. If we wanted to set a section of FFT to use as our baseline prior to the seizure, we just click where we want that range to begin, select range, we don't want that to go into the seizure, and then we'll add that baseline, just call it first, manual. And that's what that null is calculated from when we go to versus baseline FFT. Now I get a trend, and notice that, you know, spectrograms, we get this a lot of bright down the bottom, not so bright at the top, because of the amplitude differences. But again, since this is calculating z-scores, we don't have that. It's normalized across the frequency. So I'll click here. There's that seizure. And then we probably have a loss of amplitude, looks like that, after the seizure, going to those negative z-scores there. And rhythmicity. The evolving rhythmic patterns stand out pretty well. So I'm happy with this trend. Let's go ahead and close the window here. Want to save those changes? Sure. So now this trend panel is ready to go. And I could open it, the one I just saved, select template file. That's the one I made. Split the screen. And it continues along its way. And I can use any one of these to decide where to go into the EEG. Can reduce the number of channels. And apply my high frequency display. Start out with the 50 to 150, 7 microvolts. There it is. Change my page duration. Independently change the gain for my high frequency. Make measurements of these. and so on. There's a quick overview of displaying a high frequency in the waveform display, and also how to create some of the trends to trend the intracranials as well. Any questions, feel free to email me and you can get to me through support@persist.com or michael.guess@persist.com. Thanks, and hope you have a great rest of the day.